Welcome to these gentle, soothing stories for sleep. I'm so glad that you are here with me tonight. Whether you find yourself preparing to drift into dreams, unwinding after a long and winding day, or simply seeking a quiet and thoughtful companion in the stillness, you have found a safe and welcoming space. Tonight, we will begin a journey together, an exploration into one of the deepest and most personal mysteries we know, the nature of time itself. Before we begin, I would love to know where you are listening from, or perhaps just a word about how your day has been. Please feel free to leave a gentle comment below. Wherever you are, I hope you are feeling comfortable, supported, and ready to explore something truly extraordinary. And if you find these soothing scientific journeys to be a pleasant companion, please consider liking this video and subscribing to the channel. It helps more souls who are searching for peace find their way to this quiet corner of the world. Have you ever sat by the edge of a wide, slow-moving river and watched a single leaf drift by on the current? There is a profound peace in such a moment, a sense of stillness within motion. You watch the leaf appear from somewhere upstream, a place you cannot quite see, a place we might call the future. It enters your field of vision, floating gently in the present, a tiny vessel on the water's surface, and for a fleeting moment, its journey aligns with yours. You can see the intricate network of its veins, the deep green of its life, the tiny imperfections on its edges, and then, just as gracefully as it arrived, it continues on its way, drifting downstream into the past, eventually vanishing from sight, becoming a memory. In that simple, silent observation, you have witnessed the essence of how we experience time. It feels like a river, a constant, irreversible flow that carries everything with it. It moves in one direction only, from the unwritten pages of tomorrow, through the single, luminous word of today, and into the vast, silent library of yesterday. We feel this current in our very bones, in the rhythm of our breath and the beating of our hearts. It is the fundamental structure of our stories, our memories, and our hopes. But is this feeling, this deep and unwavering intuition of a flowing river, a true reflection of reality? Is time a fundamental force of the universe, an eternal current pushing the cosmos forward? Or is it something else, something stranger, something perhaps born from within ourselves? To begin to unravel this beautiful mystery, we must look not to the vastness of space, but to something as simple and familiar as a warm cup of tea held in your hands on a cool evening. Imagine the scene, the comforting heat radiating into your palms, the delicate wisp of steam rising in a gentle spiral, carrying with it a subtle aroma. The tea is hot, and the air in the room around you is cool. This difference, this separation between the hot and the cold, is a state of order. The energy is concentrated, neatly contained within the ceramic walls of the cup. But the universe has a fundamental tendency, a deep and undeniable preference, for things to become less orderly over time. The heat from your cup will not remain contained. It will inevitably and irreversibly flow outwards, warming the air around it. The steam will dissipate, its elegant spiral dissolving into the vastness of the room. Slowly, gently, the tea will cool until it reaches the same temperature as its surroundings. The energy that was once so neatly ordered will have spread out, becoming randomly and evenly distributed. The state of the world has moved from one of order to one of disorder. This principle, this universal tendency towards disorder, is one of the most foundational laws in all of physics. It is called the second law of thermodynamics, and the measure of this disorder is a concept known as entropy. This law is the reason why time seems to have a direction, why it has an arrow pointing only one way. An egg can fall from a counter and shatter into a disordered mess on the floor, but we will never see the mess of shattered shell and yolk spontaneously gather itself back into a perfect, ordered egg and leap back up onto the counter. A perfect sandcastle, built with care and precision, will always, given time, be worn down by the wind and waves into a simple, disordered mound of sand. The reverse never happens. The universe remembers the broken egg, not the whole one it came from. It remembers the flattened sandcastle, not the turreted palace it once was. The increase of entropy, the relentless march from order to disorder, is the physical process that underpins our perception of time's forward flow. The past is the state of lower entropy, the whole egg, the perfect castle. The future is the state of higher entropy, the shattered shell, the mound of sand. We are carried along on this current of increasing disorder, and it is this process that allows us to form memories. A memory, after all, is a record of a state that was more ordered than the present. And so, the river we feel ourselves floating upon seems to be this cosmic current of entropy, a universal unfolding from simplicity and order into complexity and chaos. Our minds, our bodies, our entire conscious experience is built upon this irreversible physical law, as fundamental as gravity itself. We live inside the unfolding of the universe, and we call this unfolding time. But is this human-scale river, this gentle flow we perceive through cooling cups of tea and crumbling sandcastles, the same river that flows between the stars? Does the cosmos itself keep time by the same clock? That silent, vast, and star-filled sky has been humanity's oldest and grandest clock. Long before we had gears and pendulums, long before the glowing digits on a screen, we looked to the heavens to find rhythm and measure in the universe. Imagine standing in an open field, far from the lights of any city, on a perfectly clear night. There is a deep and profound stillness, a silence that seems to stretch out to the edges of infinity. Yet, within this stillness, there is a magnificent and perfectly regular motion. You can see the slow, steady wheeling of the constellations across the celestial sphere, a majestic dance that repeats itself without fail, night after night. You can witness the moon, our closest companion, as it waxes from a slender crescent to a luminous orb, and then wanes back into darkness, a faithful and predictable cycle of phases. This cosmic waltz, this silent and dependable celestial machine, was our first encounter with a time that existed beyond the span of our own lives. It was in these cycles that we found our first units of measurement. The steady rotation of our own planet on its axis gave us the day, the fundamental rhythm of light and dark, of waking and sleeping. The gentle tilt of that axis, as our world journeyed in its vast orbit around the sun, gave us the seasons, the cycle of birth, growth, decay, and rebirth that governed our harvests and our lives. And that full journey, one complete orbit through the void, gave us the year, our measure for the passing of generations. We built our civilizations upon these cosmic rhythms. We learned to predict the flooding of rivers, the coming of winter, the right time to plant our crops, all by watching the sky. Time, for our ancestors, was not an abstract concept. It was written in the position of the sun, the phase of the moon, the location of the stars. It was a tangible, visible, and deeply sacred part of the natural world. But as our societies grew more complex, our need for a more precise and universal timekeeper grew with them. We needed to coordinate activities on scales smaller than a day and across distances where the sun might be in different positions. And so began a long and ingenious quest to create our own clocks, to bring the grand time of the cosmos down to a human scale. We built sundials, water clocks, hourglasses, and eventually the intricate and beautiful machinery of mechanical clocks, with their escapements and pendulums, their steady, reassuring tick-tock, echoing the beat of a mechanical heart. For centuries, we refined these devices, making them ever more accurate, seeking a perfect, unwavering rhythm that could serve as a single standard for the entire world. But even the finest mechanical clock will eventually drift. The most perfectly balanced pendulum is still subject to the subtle influences of temperature and friction. We needed a timekeeper more fundamental, more stable than anything we could build from gears and springs. We needed to find the most reliable rhythm in the universe itself. The answer was not found by looking out to the planets and stars, but by looking deep within, into the very heart of the atom. The clock that governs our modern world, the one that keeps our satellites in orbit, our internet synchronized, and our global navigation systems working with pinpoint accuracy, is the atomic clock. Its pendulum is not a swinging weight, but the unimaginably rapid and consistent vibration within a single atom. To be specific, we use an atom of cesium-133. In very simple terms, scientists cool a cloud of these cesium atoms to temperatures just fractions of a degree above absolute zero, the coldest possible temperature, to make them almost perfectly still. Then, they shine a microwave beam through this cloud. The electrons within each cesium atom can exist in one of two very closely spaced energy states. And when the microwave frequency is tuned just right, it causes the electrons to jump, or transition, back and forth between these two states. The atomic clock works by counting these transitions, these incredibly regular ticks. And the rate of this ticking is truly staggering. By international agreement, 1 second is defined as the time it takes for a cesium-133 atom to undergo precisely 9,192,631,770 of these transitions. This atomic heartbeat is so extraordinarily stable that the best atomic clocks in the world would not lose or gain a single second in over 300 million years. This is the source of our global time standard, Coordinated Universal Time, or UTC. It is the closest we have ever come to creating a single, unwavering heartbeat for all of humanity. In this remarkable journey from watching the slow waltz of the planets to counting the frantic pulse of an atom, we have sought to create a single, true, and universal river of time, a master clock against which all other clocks can be set. But in our very quest to define this universal time, we stumbled upon a discovery so profound and unsettling that it would forever change our understanding of reality. What if the universe has no master clock? What if time itself beats at a different rate for every single person and every single place in the entire cosmos? In our search for a perfect, universal time, we built a clock that measured the unwavering pulse of an atom, a rhythm so steady it would not falter by a single second in hundreds of millions of years. We believed we had found it, the single, true river of time that flowed at the same rate for everyone, everywhere. And yet, this very pursuit of certainty led us to the work of a young patent clerk in the year 1905, a man who would shatter our conception of a universal clock with a single, elegant thought experiment. His name was Albert Einstein, and he invited us to imagine something simple, a person on a train, moving at a constant, incredible speed. As you sit in that train carriage, the world you inhabit feels perfectly normal. A dropped apple falls straight to the floor, a thrown ball flies in a gentle arc, and the clock on the wall of your carriage ticks at a familiar, steady pace. But for someone standing still on the platform, watching your train rush past, something extraordinary and almost unbelievable is happening. Your time, from their perspective, is flowing more slowly. Your every movement, the beat of your heart, the ticking of your clock, is all unfolding in slow motion. And the faster you move through space, the more dramatic this slowing of time becomes. This is the core of Einstein's special theory of relativity, a concept called time dilation. It states that time is not absolute. It is relative to the observer. This isn't a trick of perception or an illusion. It is a fundamental property of the fabric of reality. To make this idea more tangible, physicists often tell a gentle story known as the twin paradox. Imagine two identical twins. One stays on Earth, while the other embarks on a fantastic journey into space, traveling in a starship that can approach the speed of light. For the twin in the spaceship, life feels normal. Years pass, they explore distant stars, and eventually, they turn around and come home. But upon their return to Earth, a shock awaits. The twin who remained behind is now an old man or woman, while the travelling twin has aged only a few years. They have both experienced the passage of time, but the rate of that passage was vastly different for each of them. The twin who journeyed through space at great velocity truly experienced less time. Their clock and their body ticked more slowly relative to the clock and body of their sibling on Earth. What was once a thought experiment is now a proven physical fact, verified countless times in particle accelerators, where fleeting subatomic particles can be made to last much longer by accelerating them to near the speed of light. But Einstein didn't stop there. A decade later, he expanded his theory into what we now call general relativity, and he revealed that it is not only speed that can bend and warp the flow of time. Gravity can too. His theory showed that time runs more slowly in stronger gravitational fields. A clock placed at sea level, closer to the massive center of the Earth, will tick ever so slightly slower than an identical clock placed on top of a high mountain, where Earth's gravitational pull is marginally weaker. The difference is almost unimaginably small for our everyday lives, but with our modern atomic clocks, we can measure it perfectly. This effect is not just a scientific curiosity, it is an essential piece of knowledge for our daily lives. Every time you use a global positioning system, or GPS, on your phone or in your car, you are using Einstein's theories of relativity. The GPS network relies on a constellation of satellites, orbiting high above the Earth. The clocks on board these satellites are affected by two relativistic effects simultaneously. Because they are moving at very high speeds, their clocks slow down, just like the traveling twin. But because they are high up in a weaker gravitational field, their clocks speed up, like the clock on the mountaintop. Engineers must precisely calculate and correct for both of these effects. If they did not, the tiny discrepancies in time would cause navigational errors that would accumulate at a rate of about 10 kilometers every single day, making the entire system completely useless. Einstein's strange warped clocks are not just a theory, they are ticking above our heads right now, making our modern world possible. This leads us to a staggering realization. There is no single, universal now that we all share. Your present moment is unique to you, defined by your motion and your position in a gravitational field. We each carry our own personal clock, and each one ticks at its own unique rate. If time is not absolute, if it can be stretched and squeezed, warped by speed and gravity, as if it were a physical substance, then what is it? Is it a force flowing through the universe? Or is it something more profound? Something more like a place, a dimension that we are all traveling through together? Imagine a vast, dark, and impossibly thin sheet of silk, stretched perfectly taut and held in place by some invisible cosmic frame. It is smooth, featureless, and extends in all directions as far as the eye can see. Now, imagine taking a heavy, dense ball, like a bowling ball, and placing it gently in the center of this silken fabric. The ball sinks down, creating a deep, curving well in the otherwise flat surface. The very geometry of the fabric has been changed by the presence of this mass. Now, let us take a much smaller marble and give it a gentle push so that it rolls near the edge of this gravitational well. The marble does not travel in a straight line across the fabric. Instead, its path is bent by the curvature created by the larger ball. If you give it just the right speed and direction, it will not fall into the center, but will instead enter into a stable orbit, circling the deep well again and again. This simple, beautiful image is the key to understanding Einstein's greatest insight. This fabric is what he called space-time. He realized that the three dimensions of space, length, width, and height, and the single dimension of time are not separate entities. They are inextricably woven together into a single, unified, four-dimensional continuum. And this fabric is not a passive backdrop for the events of the universe. It is an active participant. The heavy ball in our analogy represents a massive object, like our sun. The rolling marble is a smaller object, like the Earth. The Earth is not being pulled towards the sun by a mysterious, invisible force called gravity, acting across empty space. Rather, the sun's immense mass is warping the very fabric of space-time around it, creating that deep well. The Earth, in its orbit, is simply following the straightest possible path through this curved, four-dimensional landscape. What we experience as the force of gravity is nothing more than the geometry of space-time. Mass and energy tell space-time how to curve, and in return, the curvature of space-time tells matter and light how to move. It is a cosmic dance of breathtaking elegance and simplicity. This concept completely revolutionized our understanding of the universe. It explained why light from distant stars bends as it passes by our sun, and it predicted the existence of gravitational waves, ripples in the fabric of space-time, which we have now directly detected a century after he first imagined them. But this idea of time as a physical dimension, woven together with space, leads to a philosophical implication so profound that it continues to challenge our deepest intuitions about the nature of reality. It is an idea known as the block universe. If time truly is a dimension, much like the three dimensions of space, then perhaps all of time already exists. Imagine a classic reel of film. Every frame of the movie, the beginning, the middle, and the end, exists simultaneously on that reel. When you watch the movie, you experience it one frame at a time, creating the illusion of motion and the passage of time. The block universe theory suggests that reality might be like this. The entire history of the universe, from the first moment of the Big Bang to the last flicker of the most distant future, may exist as a complete, unchanging, four-dimensional block. The past, the present, and the future are all equally real, equally existent, laid out within this cosmic structure. Our conscious experience, our feeling of time's flow, might simply be our awareness moving through this block, illuminating one frame, one three-dimensional slice of space-time, at a time. We call that illuminated slice the present. In this view, the past is not gone, and the future is not unwritten. They are simply other places in the dimension of time, just as a distant city is another place in the dimensions of space. This is a staggering and deeply unsettling thought. It seems to fly in the face of our experience of an open future and the power of our choices. Are we truly making decisions, or are we simply playing out a role in a movie that has already been filmed? Physicists and philosophers are still deeply divided on this question. But this grand, physical model of time, written in the language of stars and galaxies and the very curvature of the cosmos, does not account for another kind of clock, one that is far more intimate and personal. It is the ancient, living clock that ticks away within the sanctuary of our own cells. How does this vast, cosmic fabric relate to the biological rhythms that animate our every moment? We have journeyed through the cosmos, witnessing time stretched and warped by the immense forces of gravity and velocity, and we have imagined the entire universe as a single, four-dimensional block where all of history and all of the future exist at once. This grand, physical model of time, written in the stars and in the very geometry of the cosmos, is both magnificent and impersonal. It seems to exist on a scale so far removed from our own fragile, fleeting lives. But there is another clock, another kind of time, that is unimaginably more intimate. It does not measure the orbit of planets or the curvature of space-time. It measures the rhythm of life itself, and it has been ticking away silently within our bodies long before we ever conceived of a second, a minute, or an hour. Have you ever had the gentle, mysterious experience of waking up just a few moments before your alarm clock is set to ring? In the quiet stillness of the morning, without any external cue, some part of you simply knows that it is time. This is not a coincidence. It is the work of an ancient and exquisitely precise timekeeper that you carry within you, a legacy of billions of years of life on a spinning planet. This inner timekeeper orchestrates a subtle, daily symphony of biological processes, a journey that unfolds within you from sunrise to sunset and back again. It begins with the gentle stirring of wakefulness as the first light of dawn approaches, a slow rise in energy that peaks in the mid-morning, bringing with it a natural state of alertness and focus. It guides you through the gentle lull of the afternoon, a time when the body naturally craves rest and replenishment. And as evening falls and darkness gathers, it sends the quiet, insistent signals for sleep, preparing the mind and body for the vital work of restoration that happens in the night. This entire cycle, this internal ebb and flow of energy and rest, is governed by what are known as circadian rhythms, from the Latin words circa diem, meaning around a day. These rhythms are not just a human phenomenon. They are found in almost every form of life on Earth, from the smallest bacteria to the tallest trees, a universal adaptation to the fundamental reality of our world's 24-hour rotation. It is the planet's own heartbeat, echoed in the DNA of its inhabitants. The conductor of this magnificent internal orchestra is a tiny, densely packed cluster of about 20,000 neurons, located deep within a part of the brain called the hypothalamus. This master clock is known as the suprachiasmatic nucleus, or the SCN. Despite its small size, the SCN has a monumental responsibility. It is the central pacemaker for your entire body, and it keeps itself synchronized with the outside world through a direct and powerful connection. Light. Specialized cells in the retinas of your eyes detect the ambient levels of light and send this information directly to the SCN. This signal of light in the morning is like the conductor tapping their baton, telling the SCN to start the day's performance. The SCN, in turn, sends out its own signals to virtually every organ and system in your body, ensuring that they are all working in harmony, all following the same temporal script. It dictates the release of hormones, such as cortisol to give you a burst of energy in the morning, and melatonin in the evening to induce sleepiness. It causes your body temperature to rise slightly during the day and fall at night. It even regulates your metabolism, your immune system, and your mood. This biological time is a deep and physical reality, programmed into our very cells. We are not just living in time, we are time. We are living metronomes. Our physiology, a beautiful and intricate reflection of our planet's long and graceful dance with its star. And yet, for all the precision of this ancient, cellular clockwork, our conscious feeling of time can be strangely malleable. Even when our bodies are keeping perfect time, our minds can stretch a second into an eternity, or compress an hour into a fleeting moment. This is the work of an even more mysterious timekeeper, the mind itself. There are moments in our lives that seem to step outside the steady, predictable rhythm of our biological clocks. Remember a time when you were waiting for something deeply important, perhaps for a phone call with life-changing news, or for a pot of water to finally boil when you were in a desperate hurry. Every tick of the clock on the wall seemed to echo in the silence, each second stretching out, pulling and resisting, feeling as though it lasted for a minute or more. Time became a thick, slow-moving syrup, and you were trapped within its languid current. Now, contrast this with a different memory. Think of an afternoon spent completely absorbed in a beloved hobby, or a joyful evening with dear friends, filled with laughter and heartfelt conversation. You look at the clock, and you are stunned to realize that hours have melted away in what felt like the blink of an eye. Time became a swift and weightless river, carrying you along so effortlessly that you were not even aware of its passage. These universal experiences reveal a profound truth. Our perception of time is not a fixed and objective measurement of the outside world. It is a subjective, elastic, and deeply personal reality, crafted from moment to moment by the intricate workings of our own minds. This psychological perception of time, known to scientists as chronoception, operates on a different level from the body's circadian clock. It isn't governed by the rising and setting of the sun, but by the subtle chemistry of our brains and the focus of our attention. One of the key players in this process is a neurotransmitter called dopamine, a chemical often associated with pleasure, motivation, and reward. When you are engaged in an activity that is exciting, novel, or deeply enjoyable, your brain releases more dopamine. This increase in dopamine appears to have a curious side effect. It speeds up your internal mental clock. Imagine your mind has its own private stopwatch. When dopamine levels are high, that stopwatch starts ticking much, much faster than usual. And because your internal sense of time is racing along, the external world, with its steady, clock-on-the-wall time, seems to be passing by much more quickly in comparison. This is the simple, beautiful, neurochemical basis for the old saying, "Time flies when you're having fun." It isn't just a feeling. It's a measurable change in your brain's activity. Another crucial factor that shapes our sense of time is the relationship between our attention and our memory. Our brain does not create a perfect, high-fidelity recording of every moment of our lives. Instead, it acts as a very selective editor, paying close attention to things that are new and unexpected, while largely ignoring things that are routine and familiar. This is why a vacation to a new country can feel so long and rich in retrospect. Every day is filled with novel sights, sounds, and experiences, and your brain is working hard to encode all of this new information, creating a dense tapestry of detailed memories. When you look back, the sheer volume of these new memories makes that period of time feel expansive and significant. This is the holiday paradox. It seems to fly by while it's happening because you're so engaged, but it feels wonderfully long when you remember it. In stark contrast, a week of routine work, following the same schedule day after day, creates very few distinct new memories. Your brain, running on autopilot, doesn't need to encode much. When you look back on that week, there are few memorable anchor points, and so it feels as if the entire week has vanished into a single, blurry moment. Our experience of time's passage, then, is not a direct reading of reality. It is a story our brain tells itself, a narrative whose pace is dictated by our emotions, our engagement with the world, and the richness of the memories we create. But this deep and personal connection between our minds and the flow of time raises a profound question. We feel time's arrow so strongly because we can remember the past, but we cannot remember the future. Is this fundamental asymmetry just a feature of our psychology, or does it point to the very reason time moves forward at all? Our minds, it seems, are the ultimate artists of time, capable of stretching a second into a lifetime and compressing an hour into a breath. This deeply personal, emotional, and subjective experience of time's passage feels so fundamental to who we are. And at the heart of this experience lies the most profound asymmetry of our conscious lives. The arrow of memory. Have you ever been walking down the street on a damp autumn day and caught the sudden, unexpected scent of wood smoke, and in an instant, you are no longer there on the pavement, but are transported back 20 years, a child once more, standing by a bonfire on a cool evening? Or perhaps a forgotten melody drifts from a passing car, and with it comes a perfect, vivid echo of a long-lost summer romance. This is the strange magic of memory. It is not a perfect recording, not a video camera in the mind. It is a warm, fragmented, and deeply emotional reconstruction. The past does not exist out there anymore, yet it can feel intensely, overwhelmingly real within the quiet sanctuary of our minds. We can call upon it, learn from it, and be comforted or haunted by it. The future, however, is a closed door. We can imagine it, hope for it, or fear it, but we can never, ever remember it. This one-way nature of memory, the fact that we can only gather information from the past, is the very essence of the psychological arrow of time. It is what gives our lives a sense of narrative, of progression, of becoming. But what if this psychological arrow is not separate from the physical arrow we discussed earlier, the one governed by the relentless increase of entropy? What if they are two reflections of the same deep reality? Let us revisit that idea. The second law of thermodynamics states that the universe as a whole always moves from a state of order to a state of disorder. Now, consider the act of forming a memory. In the complex and chaotic electrical storm of your brain, a memory is an act of creation, an imposition of order. A specific, stable pattern of connections is formed between neurons, a delicate and intricate piece of neural architecture that encodes a piece of your past. Creating this small island of order within your mind requires a tremendous amount of energy. Your brain, after all, is the most energy-intensive organ in your body, and the process of using that energy, the burning of calories, the metabolizing of sugars, is an inherently messy and disorderly one. It releases heat into your system, which then dissipates into your surroundings, contributing to the overall increase of entropy in the universe. Herein lies a breathtaking paradox. The very act of creating order in your mind, the act of remembering, is only possible because it is paid for by creating an even greater amount of disorder in the universe at large. It is a cosmic transaction. You can build a beautiful, ordered sandcastle of a memory, but only by using the chaotic, disordered energy of the waves. This is why the process is irreversible. This is why you cannot remember the future. To remember the future would be to create an ordered pattern in your brain that corresponds to a future event. But this would be a net decrease in the universe's entropy, a physical impossibility. The universe, it seems, is meticulous about keeping a diary, but it never writes a plan. It is filled with fossils and footprints, with craters on the moon and the light from long-dead stars that is only now reaching us. These are all records, traces of past events, memories written into the fabric of the world. But there are no fossils of the future. The arrow of memory and the arrow of entropy are one and the same. They are the reason why causes always precede effects, and why we are beings who learn and grow, constantly accumulating a past as we move into an unknown future. We are, each of us, a tapestry woven from these ordered fragments, a story held together against the gentle, persistent tide of cosmic chaos. But if our sense of time's flow is so deeply and fundamentally tied to this journey, from an initial state of order towards a future of disorder, then we are compelled to ask a truly ultimate question. What was that beginning? Where and when did the arrow of time first take flight? To find the origin of time's arrow, we must embark on a journey so vast it strains the very limits of our imagination. We must travel backwards, not just by years or by centuries, but by millennia, by millions of years, by billions of years. Let us begin this journey now, in the quiet of this moment. Let your mind drift backwards, past the memories of your own life, past the histories written in books, past the rise and fall of empires and the dawn of human consciousness. Go further still, past the age of the dinosaurs, past the time when the first complex life emerged from the primordial oceans. Watch as the earth itself coalesces from a disk of dust and gas, a fiery and molten world in its infancy. Travel further, into the deep time before our sun and solar system were ever born, back through generations of brilliant, massive stars that lived their violent lives and seeded the cosmos with the elements of which we are now made. Go back, further and further, until you see the first galaxies beginning to form, great, swirling clouds of hydrogen gas condensing in the pristine darkness. Keep going, backwards, through the cosmic dark ages, until you arrive at a moment when the entire universe was not a vast, cold, and dark expanse, but a place of unimaginable brilliance, a hot, dense, and perfectly uniform fog of plasma. And now, let us take one final step back to the very edge of our understanding, to a single point of infinite heat and density, a silence that contained all the noise that would ever be, a singularity that held within it every star, every planet, every living being, the entire past, and the entire future of our universe. This is the state from which, according to our best current understanding, everything began. The Big Bang was not an explosion in space, but an explosion of space itself, a moment of rapid, and then impossibly rapid, expansion from this primordial state. And it is in the nature of this initial state that we find the ultimate source of time's arrow. For reasons that physicists are still struggling to comprehend, the universe began in a state of extraordinarily low entropy. It was incredibly simple, smooth, and ordered. This initial, highly ordered condition is the most profound and mysterious fact about our cosmos. It is the original, perfect sandcastle, the unbroken cosmic egg, and the entire 14 billion year history of the universe since that first moment has been the story of that initial order slowly and gracefully unfolding into a state of greater and greater complexity and disorder. This continuous, relentless increase in entropy, which began with the Big Bang, is the arrow of time on a cosmic scale. Every star that burns, converting its neatly ordered fuel into scattered light and heat, is driving the arrow of time forward. Every galaxy that forms, every planet that cools, every living thing that is born, lives, and dies, is a small, temporary eddy in this great cosmic river of increasing entropy. We are not just speculating about this fiery beginning. We can still see its echo today. If you could look at the sky with eyes that could see microwaves, you would not see darkness between the stars. You would see a faint, uniform, and gentle glow coming from every single direction in the sky. This is the cosmic microwave background, the CMB. It is the oldest light in the universe, a fossil, an afterglow of creation itself. It is the light from that hot, dense plasma fog which was finally released when the universe was just 380,000 years old and had cooled enough for the fog to clear and for light to travel freely for the first time. This light has been traveling across the expanding universe ever since, and it washes over us today as a whisper of microwaves, a literal baby picture of our cosmos. It is the tangible proof that our universe did indeed begin in that hot, dense, simple state. Every tick of every clock, every beat of every heart, every thought that flickers through our minds is a direct continuation of that first primordial expansion. We are living inside the gentle, fading echo of creation, and the flow of time that we experience every moment of our lives is the universe still breathing out from that first singular breath. But if time had a definitive beginning, if the arrow was fired from the bow of the Big Bang, then our journey leads us to one last, somber question. Where is that arrow destined to land? Must it also have an end? The arrow of time, it seems, was fired from the bow of creation itself, a single, primordial moment of exquisite order that has been unfolding into complexity and disorder for nearly 14 billion years. We are living within the echo of that first release, carried along on a cosmic current of increasing entropy. We have seen how this current shapes our universe, how it gives us a past to remember and an unknown future to anticipate. But if the arrow had a definitive beginning, our journey of understanding compels us to ask a final somber question. Where is that arrow destined to land? If Time's story has a first page, must it also have a last? To contemplate this, we must once again travel in our minds, but this time, not into the distant past, but into the impossibly remote future. Picture a sky not of familiar, comforting blackness, dotted with the friendly lights of stars, but a deep, uniform, and unending emptiness, a darkness so profound and absolute that the memory of light has become a forgotten myth. Imagine that you are a silent, patient observer, watching as the last faint, red-glowing ember of the last star in the cosmos finally exhausts its fuel and flickers out, plunging the universe into a final, perfect night. This is not a fantasy. It is the logical, and perhaps inevitable, conclusion of the very same law that gives time its direction. The second law of thermodynamics, the principle that entropy, or disorder, always increases, is a one-way street. Given enough time, all the ordered structures and concentrated energy in our universe are destined to dissipate. The journey into this far future is one of immense, almost incomprehensible timescales. First, in trillions of years, the era of star formation will end as the last of the great clouds of cosmic gas are used up. The stars that exist will continue to burn, the smaller ones for trillions more years, until they too fade into cold, dead remnants like black dwarfs and neutron stars. The galaxies themselves will slowly dissolve, their dead stars cast out into the growing emptiness by gravitational encounters. The universe will become a ghostly and desolate place, populated only by these stellar corpses and by the silent, gravitational behemoths we call black holes. But even this is not the end. Over timescales so vast that our human minds cannot truly grasp them, even the very substance of matter itself may be fated to disappear. Some physical theories suggest that protons, the stable building blocks of atoms, will eventually decay, causing all the dead stars and planets and dust to slowly evaporate into a thin mist of radiation and elementary particles. The only organized structures left in the entire universe will be the black holes, patiently consuming any matter that falls into their grasp. And then, in the final act of the cosmos, even they will begin to die. Through a process theorized by Stephen Hawking, known as Hawking radiation, black holes will slowly, almost imperceptibly, radiate their mass and energy back into the void. The smaller ones will go first, and the supermassive giants at the hearts of long-dead galaxies will take an almost infinite amount of time. But they too will eventually evaporate, their final moment marked by a faint pop of energy in the unending silence. When the last black hole has vanished, the universe will have reached its final state. It will be a vast, cold, and featureless soup of dilute particles and low-energy radiation, spread perfectly evenly throughout an enormously expanded space. This is the state of maximum entropy, the theoretical heat death of the universe. In this final equilibrium, there are no temperature differences, no concentrations of energy, no ordered structures left anywhere. And because there is no order, no processes can occur. No work can be done. Nothing, anywhere, can ever happen again. In a universe where nothing happens, where no change is possible, does time still flow? If time is the measure of change, then a changeless universe is a timeless one. The arrow would have finally landed, not into a target, but into a state of perfect stillness. It would be an eternity, not of infinite duration, but of a single, unending, silent moment. This linear path, from a fiery, ordered beginning to a cold, disordered end, feels so absolute, so final. But what if nature, on its grandest and most beautiful scale, prefers circles to straight lines? What if the end is not an end at all, but somehow another beginning? Imagine yourself standing on the shore of a vast and mysterious ocean. The waves roll in with a steady, hypnotic rhythm, and as each one washes over the sand, it erases the world that was there a moment before, leaving a smooth, clean slate. And in the very next moment, a new wave arrives, creating a new world of ripples and patterns, only for it to be washed away in turn. In this place, there is no final end, only the endless, gentle cycle of creation and dissolution. This deep, cyclical pattern is woven into the fabric of our own world, a rhythm that nature seems to favor. We see it in the turning of the seasons, as the death of winter gives way to the new life of spring, year after year. We see it in the water cycle, as vapor rises from the sea to form clouds, falls as rain to nourish the land, and flows in rivers back to the sea from which it came. We see it in the very fabric of life and death, the decomposition of the old providing the nutrients for the new, in an unbroken chain stretching back for billions of years. Nature seems to abhor a final, definitive end, preferring instead the gentle poetry of endless regeneration. Could it be that the universe itself, on its most magnificent scale, follows this same pattern? Could the silence at the end of time be not a final note, but merely a pause before the symphony begins anew? This is the beautiful and mind-expanding possibility offered by some of the most forward-thinking theories in modern cosmology. One of the most elegant of these is an idea proposed by the great physicist and mathematician Sir Roger Penrose, known as conformal cyclic cosmology, or CCC. This theory invites us to look again at that final state of the universe, the cold, dark, and empty void of heat-death that we explored a few moments ago. In that ultimate future, the universe is filled only with a dilute mist of massless particles, like photons, the particles of light. In a universe containing only things that move at the speed of light, the very concepts of time and distance lose their meaning. There is nothing to measure scale against. From the perspective of a photon, its journey from emission to absorption happens in an instant, regardless of the distance traveled. Penrose realized that this strange, scale-free geometry of the infinitely large, cold, and empty future of our universe is, in a mathematical sense, almost identical to the geometry of the infinitely small, hot, and dense beginning of a universe in a Big Bang. His theory suggests that the universe proceeds in a series of cycles, which he calls aeons. Our universe, our aeon, began with a Big Bang, and it will expand and expand for trillions upon trillions of years until it reaches that final, empty state of heat death. But that end is not a true end. The vast and empty future of our aeon becomes, through a kind of cosmic rescaling, the perfectly smooth and dense Big Bang of the next aeon. The story starts over. The end of one universe is the seed of the next. In this breathtaking vision, time is not a finite line segment, beginning at a point and ending at a point. It is a great, unending circle. Our entire cosmic history, the formation of every galaxy, the birth of every star, the whole of life on Earth, could be just one single, magnificent chapter in an infinite, eternal book. There may have been countless universes before ours, and there may be countless more to come, each one born from the cold ashes of the one before. This idea transforms the somber prospect of heat death into something deeply hopeful. It suggests that the cosmos itself is a part of an eternal cycle of renewal, that the end is always, and forever, a new beginning. But whether time is a straight line or a perfect circle, these vast theories of cosmic beginnings and ends all treat it as a fundamental feature of the universe. Yet, there is a place where our understanding of time and of reality itself completely breaks down. It is a realm of shimmering probability and profound uncertainty, where the very idea of a smooth flow might be nothing more than a stubborn illusion. We must now turn our gaze from the infinitely large to the impossibly small, to the strange and wonderful world of quantum physics. We have journeyed to the beginning of time and contemplated its possible end, following a great arrow that seems to be written into the very fabric of the cosmos. We have seen this arrow in the relentless increase of entropy, in the grand, cyclical breathing of possible universes, and in the deep, biological rhythms of our own bodies. But all of these explorations have assumed that time is a smooth and continuous river, a current that flows without interruption. We have gazed at the vastness of the cosmos, but now we must turn our attention in the opposite direction, shrinking ourselves down, past the scale of molecules and atoms, into a realm so impossibly small and strange that all of our intuitions about reality begin to dissolve like mist. This is the world of quantum physics, the fundamental level of existence, and here, the river of time does not seem to flow at all. Imagine you are watching an old film on a projector. If the film moves quickly enough, you see a seamless, continuous motion on the screen. But if you were to slow it down, frame by frame, you would see that the illusion of motion is created by a series of static, unmoving pictures, each one instantly replacing the one before it. What if the universe itself operates in this way? Let us begin with the image of a magnificent waterfall, a great, continuous curtain of white water thundering down into a pool below. From a distance, it is the very picture of smooth, powerful, and ceaseless flow. But as you walk closer, the singular curtain dissolves into a complex spray of billions upon billions of individual, discrete droplets of water. The smooth flow was an illusion, a macroscopic effect created by the collective behavior of countless tiny, separate parts. The quantum world reveals that our reality is much the same. At this fundamental level, change does not happen smoothly. Consider an electron orbiting the nucleus of an atom. We might picture it like a tiny planet orbiting a sun, capable of moving in a smooth path from one orbit to another. But this is not what happens. An electron can only exist in specific, allowed energy levels, or orbits. To move from a lower orbit to a higher one, it must absorb a precise amount of energy, and when it does not travel through the space in between. It simply vanishes from the lower orbit and instantly reappears in the higher one. This instantaneous transition is a quantum leap. It is as if a person standing on the first floor of a building could instantly appear on the 10th floor without ever having been on floors 2 through 9. This strange, jumpy nature of reality might not just apply to the position of particles, but to time itself. Some theories in physics suggest that time, like light, may come in tiny, indivisible packets, or quanta. There may be a smallest possible unit of time, a fundamental tick of the universal clock, below which the very concept of duration ceases to exist. This is known as the Planck time, an almost unimaginably short interval, equal to roughly 10 to the power of negative 43 seconds. If this is true, then time is not a smooth, continuous river. It is pixelated. The universe lurches forward in these impossibly tiny, discrete steps, like the frames of that cosmic film projector. The smooth flow we experience is an illusion created by the rapid succession of these frozen, static moments. This idea becomes even more profound when we encounter one of the most perplexing and foundational equations in theoretical physics. It is called the Wheeler-DeWitt equation, and it is an attempt to apply the laws of quantum mechanics to the universe as a whole. But the equation holds a deep secret. When you write it down, the variable for time, the 8 that is present in almost all other physical equations, is simply not there. The equation describes a static, timeless, unchanging universal wave function. This has led some physicists to a radical conclusion. Perhaps, at the most fundamental level, time does not exist at all. Perhaps it is not a feature of the universe as a whole, but something that only appears when we look at its individual parts. We seem to be left with a profound and dizzying disconnect. Our deepest experience of reality is one of constant change, of becoming, of flowing through time. Yet the bedrock of that reality, the quantum world from which it is all built, may be a place of discrete, static snapshots, a timeless and frozen realm. If this is so, then where does our river of time come from? How does the universe bridge the immense gap between the quantum jump and the river's gentle, continuous flow? We find ourselves at the edge of a great chasm in our understanding. On one side, there is the quantum world, a strange and static place of frozen moments and instantaneous leaps, a reality that seems to exist outside of time. On the other side, there is our world, the familiar, classical reality of our senses, a place of smooth motion, of continuous change, of causes and effects unfolding along a steady, flowing river of time. How does one world give birth to the other? The answer may lie in one of the most beautiful and powerful ideas in all of science, a concept that explains how complexity and order can arise from simplicity and chaos. To grasp this idea, let us begin with a simple question. Think of a single molecule of H2O. It is a tiny, V-shaped arrangement of 3 atoms. Does this single molecule have the quality of being wet? Is it fluid? Does it have a temperature? The answer to all of these questions is no. A single molecule of water is not wet. Wetness is not a property of one molecule. It is a property that emerges only when you have a vast collection of trillions upon trillions of these molecules, all tumbling over one another, all interacting and forming fleeting bonds. Wetness is a property of the collective, not of the individual part. This is the principle of emergence. It is the magic by which complex systems and patterns arise from the interaction of many simple components, with the system as a whole displaying properties that are not present in the components themselves. You can see this principle everywhere you look in the natural world. Think of being in the middle of a large, bustling crowd. From your perspective on the ground, it is a chaos of individuals, people moving in every direction for their own reasons. But if you were to look down from a high vantage point, you would see clear, ordered patterns. You would see rivers of people flowing down certain streets. You would see eddies and currents forming at intersections. You would see the crowd behaving, in some ways, like a single, fluid organism. This flow is a property of the crowd, not of any single person within it. Or consider a flock of starlings, a great murmuration that paints breathtaking, shifting patterns in the evening sky. There is no leader, no choreographer. This complex, coordinated dance emerges from each individual bird following a few very simple rules, such as staying close to its neighbors, but not too close, and matching their general direction and speed. The intricate beauty of the whole emerges from the simplicity of the parts. What if time itself, and specifically its relentless, forward-pointing arrow, is an emergent property? What if the smooth flow we perceive is not a fundamental law of physics, written into the fabric of reality at the deepest level, but is instead like the wetness of water or the flow of a crowd, a property that only comes into being in a large, complex, macroscopic universe like ours? This is a leading idea in modern physics. The strange, timeless quantum world is governed by probabilities and possibilities. A single particle can be in many places at once, in a state called superposition. But when that quantum system interacts with its wider environment, when it is measured, or observed, or simply bumps into other particles, it is forced to choose one single, definite state. This process is called quantum decoherence, and it is the bridge between the quantum world and the classical world. It is through these countless, constant interactions that the shimmering, uncertain quantum possibilities collapse into the single, solid, predictable reality that we experience. The arrow of time, then, might be the statistical, large-scale result of this ongoing process of decoherence. The past is the realm where all the quantum possibilities have already collapsed into a definite, settled history. The future is the realm of open, shimmering possibilities, still waiting to be resolved. The present is the constantly moving boundary where this resolution is happening. The relationship between the timeless quantum world and our temporal world is like the relationship between a single thread of cotton and a great tapestry. The thread itself has no image, no story. But when you weave it together with billions of other threads, a rich, detailed, and coherent picture emerges. Our sense of a definite past and an open future, our entire experience of time's flow, could be the grand, emergent picture that is woven from these countless timeless quantum threads. This suggests that time is not an absolute dictator of reality, but rather a collective agreement, a pattern that reality settles into on our scale. It is profoundly real for us, here in the tapestry, even if it is not present in the individual threads from which we are made. But if time emerges from the countless interactions happening all around us, and if every interaction can be thought of as a transfer of information, then perhaps we are looking at this mystery from the wrong angle. Could it be that the story of time is actually the story of information itself? We have arrived at a remarkable place in our journey, a place where the smooth, flowing river of time we experience seems to emerge from the strange, jerky, and timeless world of quantum mechanics. This emergence, like the wetness of water or the flocking of birds, suggests that time is not a fundamental dictator of reality, but a collective property of a complex universe. But this very idea of emergence, of a coherent whole, arising from the interaction of countless parts, forces us to ask an even deeper question. Every interaction, from the collision of two particles to the fusion in the heart of a star, can be thought of as a transfer or a processing of information. What if that is the true foundation of it all? What if the universe is not fundamentally made of matter and energy, but of information itself? Look for a moment at the words you might see on a printed page. They are made of physical ink, of course, but their true essence is not the ink. It is the information they carry, the stories they tell, the ideas they convey. The physical it of the ink is merely a vessel for the conceptual bit of the information. Could the same be true for a particle, a planet, or the entire cosmos? Imagine walking through a vast and silent library, a library that contains everything. Each book on its infinite shelves does not contain a story in our human sense, but rather a complete description of one possible state of the entire universe, every particle's position and momentum written on its pages. The history of our universe, in this analogy, is the process of turning from one page to the next. The flow of time is the unfolding of this cosmic narrative. This is the core of a powerful idea in modern physics, summarized beautifully by the physicist John Wheeler in the simple phrase, "it from bit." This is the proposition that the physical world, the world of particles, fields, and forces arises from a deeper, more fundamental reality, made of information, of bits. Every elementary particle can be described completely by a handful of properties. Its mass, its charge, its spin. These properties are nothing more than answers to yes or no questions, the fundamental units of information. Perhaps a particle is not a tiny, solid thing, but a manifestation of the information that describes it. This informational perspective gives us a profound new way to understand the arrow of time. Let us return to the concept of entropy. We first met it as a measure of disorder, the reason why a hot cup of tea always cools down. But in the language of information theory, entropy has another, equivalent meaning. It is a measure of our uncertainty, or our lack of information, about a system. Think of a brand new deck of cards, perfectly ordered by suit and number. This is a state of very low entropy. It contains very little information because its state is completely known and predictable. It can be described with a very simple instruction. Cards are in order. But if you shuffle that deck thoroughly, it enters a state of high entropy. It is now disordered, yes, but it also contains a vast amount of information. To describe its specific, shuffled state, you would have to name every single one of the 52 cards in its new, random sequence. The arrow of time, the relentless increase of entropy, can therefore be seen as the universe's information content becoming more and more complex and less predictable. The low-entropy Big Bang was like that new deck of cards, a state of profound simplicity that required very little information to describe. The 14 billion years since have been a grand, cosmic shuffle, increasing the universe's complexity and the amount of information needed to describe it. This connection between physical reality and information is strengthened by one of the most mind-bending ideas to come from the study of black holes, the holographic principle. It suggests, in essence, that all of the information contained within a three-dimensional volume of space can be completely and perfectly encoded on its two-dimensional boundary, just like a hologram. This radical idea hints that our seemingly solid, three-dimensional reality might be a projection of information stored on a distant, two-dimensional surface. If the universe, at its heart, is a flow of information, a great cosmic computation unfolding according to logical rules, then what are we? Are we not also complex informational processes? And if reality is a message being written, a story being told from page to page in that great cosmic library, who, or what, is the observer? This question leads us away from the cosmos and back to the only observer we can ever truly know, our own consciousness. Is our perception of a moving now just a passive reading of this cosmic information, or does it play an active, and perhaps even essential, role in creating the flow of time itself? Let us try a small, gentle experiment, right here in the quiet of this moment. Try to pinpoint the exact, infinitesimal instant of now. As you focus your attention upon it, notice how it immediately slips away, becoming the past before you can ever truly hold it. The present moment is the most real thing we have, the only place where we ever truly live, and yet it is as elusive as a single drop of water in a flowing river, as ungraspable as a beam of light. This elusiveness points to a deep truth about our relationship with time. Our conscious experience is not a perfect, high-resolution camera, capturing each instant as it happens. It is something far more creative, more complex, and more beautiful. To feel this, take a moment to simply be present with your senses. Perhaps you can feel the gentle pressure of the air on your skin, or hear the distant, soothing hum of the world outside your window, or see the soft, flickering dance of a candle flame. Your brain is receiving all of these sensory inputs, touch, sound, sight, and weaving them together into a single, unified, coherent experience that you call now. But what is truly remarkable is that these different signals travel through your nervous system at different speeds. The signal for touch is faster than the signal for sound, which is faster than the signal for sight. And yet, you do not experience a disjointed reality where you feel a touch, then hear a sound, then see the cause. Your brain performs a masterful act of editing, waiting for all the relevant information to arrive, and then presenting it to you in one seamless, synchronized package. This package, this subjective experience of the present, is what neuroscientists call the specious present. It is not an infinitely thin slice of time. It is a small but crucial window of duration, a temporal field of awareness that is estimated to last for around 2 to 3 seconds. Everything that occurs within this small window is perceived by our consciousness as happening now. It is because of this temporal window that we can perceive a melody, rather than just a series of disconnected notes. It is why we can perceive motion, rather than just a sequence of static images. Our brain gathers up the immediate past, the sensory data from the last couple of seconds, and presents it to us as a flowing, continuous present moment. The now that we inhabit is not a direct perception of an objective reality, but a brilliant story that our brain tells itself. A story that is constantly being updated, a masterpiece of neural editing designed to give us a stable and coherent world to live in. We are, in a very real sense, always living in the very recent past. This idea of the conscious mind as a creator, rather than a passive observer, of our temporal reality takes on an even deeper significance when we return to the strange world of quantum mechanics. As we saw, a quantum particle can exist in a cloud of multiple possibilities at once, a state of superposition. But when it is measured, this cloud of possibilities collapses into one single, definite reality. The great mystery has always been, what constitutes a measurement? For most physicists, an interaction with any macroscopic object is enough. But a small and thought-provoking minority have, over the years, subscribed to a more radical idea, known as the von Neumann-Wigner interpretation. This interpretation suggests that the one thing truly unique enough to collapse a quantum wave function is the act of observation by a conscious mind. In this view, it is the beam of consciousness itself that turns the shimmering quantum possibilities of the future into the concrete, settled reality of the past. While this is not a mainstream scientific view, it poses a question of breathtaking importance. Is consciousness the loom upon which the tapestry of space-time is woven? Is our act of witnessing the universe what makes it definite? Perhaps our subjective feeling of time's flow is not just an illusion or an emergent property, but is intimately linked to the fundamental process by which reality itself becomes real. We are left with the profound idea that our experience of the present is a beautiful construction, a story told by our brain about a world our consciousness may be helping to create. But this entire exploration has been centered on the workings of a human mind, on a human timescale. We share this world with beings whose entire existence unfolds in rhythms and durations that are profoundly alien to our own. What is the nature of time for a tree that lives for 1,000 years, or for a mountain that exists for 1,000,000,000? Our journey into the nature of time has led us to a place of profound intimacy, to the inner world of our own consciousness. We have discovered that the solid, flowing now that we experience is a beautiful and intricate construction, a story told to us by our own minds. But this story, this perception, is filtered through a uniquely human lens, calibrated to the rhythm of a human heartbeat and the span of a human life. We have built our understanding of time around ourselves. But what happens to that understanding if we have the humility to step outside of our own perspective? What is time to the other inhabitants of our world? The silent, patient beings who experience existence on scales so slow or so fast that they might as well be living in different universes. Place your hand, just for a moment in your imagination, upon the rough, ancient bark of a great tree. Feel the immense stillness, the deep-rooted peace of a being that has stood in this one spot for centuries. Can you feel, beneath that quiet surface, the slow, imperceptible rush of water from the deep earth to the highest leaf? A life lived at a pace 1,000 times slower than your own. Let us try to see the world through the eyes of such a being, to embark on a journey in time-lapse. Imagine our frantic human world speeding up around the patient gaze of this ancient tree. The sun and moon do not crawl across the sky. They streak across it like brilliant comets. Day and night become a frantic, pulsing strobe of light and dark. The slow, graceful turning of the seasons blurs into a single, continuous cycle, a breath of green in the spring and a breath of gold in the autumn, repeated over and over again. Entire generations of animals, of birds and insects, and small mammals flicker in and out of existence in the undergrowth. Their entire lives a brief and fleeting shimmer. Human buildings rise and fall on the horizon like curious mushrooms. A human lifetime, from this perspective, is but a flash of lightning in a long, slow summer afternoon. This is not just a poetic fancy, it is a biological reality. A mayfly, hatched from its larval state, experiences its entire adult life of courtship and reproduction in the span of a single one of our days. Its internal clock, its perception of the world, must be calibrated to this frantic, compressed timescale. In contrast, a bristlecone pine, clinging to a high mountain slope, can live for 5,000 of our years. Its present moment, its experience of growth and change, is drawn out over a vast and patient canvas. And we can stretch this perspective even further, beyond the realm of the biological, into the immense, silent world of the geological. Imagine the consciousness of a great mountain. Its sense of time is not measured by heartbeats or by seasons, but by the slow, inexorable crush of tectonic plates and the patient, gentle erosion of wind and rain. For a mountain, a human century is less than the blink of an eye. The rise and fall of our entire civilization is a fleeting shimmer of activity on its surface, a brief warmth that quickly fades. The mountain remembers the slow retreat of the last great glaciers, and it waits for the slow advance of the next. This is the world of deep time, a timescale so vast that it shrinks our human concerns, our urgent deadlines, and our fleeting worries, down to their proper, humble size. There is no single, universally correct speed for time to flow. There is only the frantic time of the mayfly, the patient time of the tree, the deep time of the mountain, and our own, human time, nestled somewhere in between. Our perception is entirely relative to our lifespan and our metabolic rate. Realizing this can be a profound source of peace. It reminds us that we are a part of a much larger, slower, and more patient story. We are a brief, beautiful, and frantic flicker in the deep, slow time of the earth. But our human pace, our restless minds, led us to do something that no tree or mountain has ever done. We were not content to simply live within the natural rhythms of our world. We sought to capture time, to measure it, to tame it. We built a machine to tell us what time it was, and in doing so, we changed not just our lives, but our very relationship with reality. Before the steady, relentless ticking of a clock became the soundtrack to our lives, the world experienced time in a profoundly different way. How did people agree to meet? They met when the sun was at its highest point in the sky, or after the evening prayer was finished, or when the cows were brought in from the fields for milking. Time was not an abstract, invisible grid laid over the world. It was rooted in the tangible, recurring events of nature and of daily life. It was a local and a cyclical thing. Noon in one village was slightly different from noon in the next, and the rhythm of the year was not measured in months and dates, but in the great, repeating cycles of planting and harvesting, of feast and of famine, of the long, slow nights of winter and the bright, endless days of summer. This was a human time, a time that was flexible, organic, and deeply connected to the world around us. But a profound revolution was coming, a quiet invention that would fundamentally re-engineer our perception of reality. It was the invention of the mechanical clock. Imagine, for a moment, the sensory difference between these two worlds. Picture a day lived on a small farm centuries ago. Your waking is governed by the first light of dawn, your work in the fields by the position of the sun, your meals by the rumbling of your stomach, and your sleep by the falling of darkness and the feeling of a body spent from good, hard work. The day has a natural flowing shape, a rhythm of effort and rest that is in constant dialogue with the living world. Now, contrast that with a day in a modern city. Your waking is commanded by the shrill, numerical demand of an alarm clock. Your day is divided into a series of discrete, abstract blocks. The 9 o'clock meeting, the 1 o'clock lunch break, the 5 o'clock deadline. You move from one appointment to the next, your life synchronized not with the sun, but with a universal, invisible, and unforgiving time standard. The day is no longer a flowing river. It is a series of boxes to be checked. This transformation began quietly in the monasteries of medieval Europe, where monks needed a way to regulate their 7 daily prayers. The first mechanical clocks were not built to tell the time of day to the public, but to ring a bell to call the faithful to their duties. But this new technology, this ability to create a steady, repeatable, mechanical rhythm, soon spilled out of the monastery walls and into the public square. The great clock towers of the late Middle Ages became the new heart of the city. For the first time, an entire community could organize itself around a single, authoritative, and abstract measure of time. This new kind of time was radically different from what had come before. It was no longer tied to the sun or the seasons. It was linear, not cyclical. It was uniform, the same for everyone, everywhere. And because it could be divided into equal, repeatable units of hours, minutes, and seconds, it could be measured. And anything that can be measured can be bought and sold. Time became a commodity, a resource that could be spent, saved, wasted, or used efficiently. This conceptual shift, from time as an experience to time as a resource, was one of the most important in human history. It paved the way for the Industrial Revolution. The synchronized labor of a factory, with hundreds of workers starting and stopping their machines at the same moment, would have been impossible without it. The complex timetables of the railroads, which connected nations and continents, depended entirely on a standardized, clock-driven time. Our entire modern global economy, with its instantaneous financial transactions and its meticulously planned supply chains, is built upon the silent, invisible scaffolding of clock time. The clock did not just measure our days, it fundamentally reshaped them, and in doing so, it reshaped our minds and our societies to fit its own mechanical, relentless rhythm. In this process, we gained a level of efficiency and coordination that our ancestors could never have dreamed of. But what might we have lost? Perhaps we have lost a connection to a more natural, more forgiving, and more human sense of time. We learned to serve the clock, instead of having it serve us. And yet, sometimes, even in our modern, clock-driven world, we find moments of escape, moments of deep absorption and joy, where the entire rigid structure of measured time seems to dissolve away into meaninglessness. What is this magical feeling, and what can it teach us about our true nature? We have built for ourselves a world that runs on the steady, mechanical heartbeat of the clock. Its relentless ticking has allowed us to coordinate our complex societies, to build our global economies, and to embark on great scientific endeavors. But in learning to serve this master, we have perhaps forgotten a more ancient and natural way of being, a way of moving through the world where time is not a resource to be managed, but an experience to be lived. And yet, even in our meticulously scheduled lives, there are moments of grace, moments of escape, when the clock on the wall seems to fade into irrelevance, and we step into a different kind of reality. Think back to a time when you were completely and utterly absorbed in an activity you love. Perhaps it was painting, the world dissolving into nothing but the canvas and the color on the end of your brush. Perhaps it was playing a musical instrument, your sense of self melting into the sound waves flowing from your fingertips. It could have been gardening, writing, hiking in the mountains, or even a deep and heartfelt conversation with someone you trust. Do you remember that feeling? The outside world seems to fade away. The chorus of worries, plans, and self-conscious thoughts in your mind grows quiet, until it falls completely silent. There is no past to regret, no future to worry about. There is only the simple, profound, and joyful reality of what you are doing in this very moment. And then, when you finally look up, you are startled to realize that hours have passed in what felt like mere minutes. This beautiful and deeply sought-after state of consciousness has a name. It was identified and described by the psychologist Mihaly Csikszentmihalyi, who called it flow. It is a mental state of being fully immersed in an activity with energized focus, full involvement, and deep enjoyment. Decades of research have shown that flow is not just a pleasant feeling, it is one of the key sources of genuine and lasting happiness and fulfillment in human life. This state does not arise by accident. It tends to occur under a specific set of conditions. First, the activity must have a clear set of goals. You know what you are trying to achieve, moment by moment. Second, it must provide immediate feedback. You can see the results of your actions as you perform them, allowing you to adjust your course in real time. And third, and perhaps most importantly, there must be a perfect balance between the level of challenge the activity presents and your own level of skill. If the challenge is too high, you feel anxiety. If it is too low, you feel boredom. But right in that delicate, perfect channel between boredom and anxiety, the state of flow can emerge. When we enter this state, our brains behave in a remarkable way. Neurological studies have shown that during moments of peak flow, a part of the brain called the prefrontal cortex shows a significant decrease in activity. The prefrontal cortex is, in many ways, the seat of our conscious, individual self. It is where we do our long-term planning, our abstract analysis, and our self-conscious rumination. It is the home of our inner critic, the voice that is constantly judging our performance and worrying about what others think of us. The temporary shutting down of this area during flow is why our sense of self seems to dissolve. The ego gets out of the way, and action and awareness merge into one. And because the prefrontal cortex is also heavily involved in our conscious tracking of time, as it quiets down, our perception of duration simply fades away. We become, in a sense, timeless. These moments of flow are a gentle but powerful reminder that our deepest and most meaningful engagement with life often happens when we forget about time altogether. They are moments of pure being, lived outside the artificial and rigid cage of the clock. They hint at a truth that our frantic, modern world often encourages us to forget, that our lives might be measured not by their duration, but by their depth of engagement. This deliberate cultivation of a timeless state, however, is not just for our hobbies and our passions. For millennia, great spiritual and contemplative traditions from all over the world have taught that the greatest wisdom and the deepest peace lies in learning how to step out of the rushing stream of linear time altogether. What do they know that our science and our psychology are only now beginning to touch upon? Let us begin this part of our journey with a single, gentle breath. Just for this moment, if you feel comfortable doing so, allow your attention to rest on the simple, physical sensation of your breathing. Feel the air as it enters, cool and fresh, and feel it as it leaves, warm and soft. In this simple, elemental act, there is no past and there is no future. There is no story, no judgment, no plan. There is only the feeling of this breath, this life, happening right now. For as long as humanity has contemplated the mysteries of existence, there have been wise traditions that have pointed to this simple, profound truth. The ultimate reality is not to be found in the grand sweep of history or the anxious anticipation of tomorrow, but in the still, quiet, and eternally available present moment. These contemplative traditions, such as Zen Buddhism, Taoism, and the ancient philosophy of Stoicism, are not so much religions as they are profound technologies of the mind. They each recognize that a great deal of human suffering arises from a simple mistake in our thinking. We become mentally trapped in a time that does not exist. We live our lives lost in thought, endlessly replaying the regrets and resentments of the past, or anxiously rehearsing the fears and desires we have for the future. In doing so, we miss the only thing that is ever actually real, the life that is unfolding right in front of us, right now. The core practice that these traditions develop to address this condition is what we now often call mindfulness. Mindfulness is the simple, yet transformative, art of paying attention, on purpose, to the present moment, without judgment. It is the practice of gently bringing your awareness back, again and again, from the wandering stories of the mind to the direct, sensory reality of your life as it is. It is feeling the warmth of the sun on your skin, truly tasting the food that you eat, truly hearing the voice of a loved one. This is not a practice designed to stop time, which is an impossibility, but rather to fundamentally change our relationship to it. When we are mindful, we step out of the rushing, frantic river of psychological time and come to rest on the quiet, stable bank of the present moment. From this peaceful vantage point, the thoughts of past and future can still flow by, but they are no longer a torrential current that sweeps us away. They become like clouds passing in the sky, observed with a gentle and compassionate awareness, but not mistaken for the sky itself. This ancient wisdom has a fascinating and beautiful resonance with the strange, cutting-edge physics that we explored earlier. Remember the idea of the block universe, the theory that all of time past, present, and future may exist simultaneously, as a complete, four-dimensional reality. If all moments are, in a sense, equally real and existent, then the only one we can ever truly access, the only point of contact we can ever have with this block of reality, is the moment our consciousness is currently illuminating. It is this present moment. The eternal now spoken of by mystics and sages is not, therefore, an infinitely long period of time. It is the discovery of the timeless quality that is inherent in any given moment when it is fully inhabited by our awareness. It is the realization that this moment, right now, is the only home we will ever have. Perhaps the ultimate answer to the grand, cosmic question, is time real, is actually a deeply personal one. The past is real, but only as a memory, a concept in our minds. The future is real, but only as an imagination, a projection of what might be. The only thing that is ever truly, experientially real for us is this present moment. This is where our life happens. We have traveled on an immense journey together, from the simple image of a flowing river to the vast expanse of the cosmos, from the beginning of the universe to its possible end, from the gears of a clock to the quiet stillness of our own consciousness. Now, let us begin to gather these many beautiful and complex threads. What profound and gentle picture do they weave? We have traveled together on a journey of immense and breathtaking scale. We began our quiet contemplation sitting by the edge of a gentle river, and from there, we have journeyed to the heart of a ticking atom, to the warped and woven fabric of space-time, to the fiery dawn of the Big Bang, and into the silent, waiting stillness at the end of time. We have explored the ancient, biological clock that beats within our very cells, and the elastic, emotional time that our minds create from moment to moment. We have seen time as a relentless arrow of increasing disorder and as a great, cosmic circle of eternal renewal. We have peered into the strange, timeless quantum realm, and we have rested in the profound peace of the present moment. And now, at the end of this long exploration, we are left with all these beautiful and sometimes conflicting threads of understanding. What are we to make of it all? Imagine holding a crystal prism up to a single, pure beam of white sunlight. The light that enters the prism is one unified thing, but what emerges on the other side is a brilliant, shimmering rainbow of distinct and individual colors. Perhaps time is like that beam of white light. It is a single, simple word in our language, but when we look at it through the prism of deep inquiry, it reveals itself to be a spectrum of many different, yet interconnected, realities. Let us gather these beautiful colors, these threads of our story, and see how they weave together. There is the profound and undeniable reality of physical time. This is the time of the physicist, a fourth dimension woven into the fabric of space-time, a dimension that can be bent by gravity and stretched by velocity. Its forward direction, its irreversible arrow, appears to be governed by the most fundamental law of the universe, the relentless increase of entropy. This time is as real as a mountain, as real as a star. Then there is the deep and ancient reality of biological time. This is the time of the biologist, the circadian rhythm that is written into the DNA of nearly every living thing on Earth. It is the master clock in our brains that synchronizes our bodies with the rising and setting of the sun, a legacy of our planet's long, slow dance through space. This time is as real as our own heartbeat. There is also the vivid and intensely personal reality of psychological time. This is the time of the psychologist, the subjective and elastic experience of duration that is shaped by our emotions, our attention, and the richness of our memories. It is the reason why time can fly when we are joyful and drag when we are in pain. This time is as real as our own feelings. And finally, there is the powerful and pervasive reality of social time. This is the time of the historian and the sociologist, the abstract grid of hours, minutes, and seconds that we have collectively invented and imposed upon the world. It is the time of the clock and the calendar, a human construction that has enabled the rise of our global civilization. This time is as real as the societies we have built. So, we must return to the question that began our entire journey. Is time real, or is it just a concept? We can now see that this is perhaps the wrong question, for it presents us with a false choice. The truth is not either or, but both and. Time is a real, physical feature of the universe, and it is also a concept that we, as conscious, biological, and social creatures, construct and perceive in many different ways. To help us hold this complex thought, we can use an analogy. Consider the word love. Is love real, or is it just a concept? It is, of course, both. Love is a very real neurochemical process in the brain, a cascade of hormones and neurotransmitters. It is a real biological imperative, a drive for connection that is written into our evolutionary history. And it is also a profoundly personal and culturally shaped concept, an idea that poets and philosophers have tried to capture for millennia. Love is a multi-layered reality. Time, in all its mystery and its majesty, is no different. The quest to understand it is not about finding a single, final, simple answer that will vanquish all the others. It is about learning to hold all of these truths in our minds at once, to appreciate the richness and the complexity of the whole. The mystery of time is not a problem to be solved, but a profound wonder to be lived within. And so, our grand cosmic journey brings us back, at last, to the human scale, to the only time that we can ever truly know. Given all this wonder, given all this complexity, how then shall we live within our own precious and fleeting moments? At the very beginning of our journey together, we sat by the edge of a wide, slow-moving river and watched a single leaf drift by on the current. Let us return to that riverbank now, in the quiet of this final chapter. The leaf is still there, floating on the water's surface. It does not struggle against the current, nor does it try to rush ahead of the flow. It does not cling to the memory of the branch from which it fell, nor does it live in anxious anticipation of the great ocean It may or may not be destined to reach. It simply rests in the flow of this moment, its journey and its destination all contained in the simple, profound act of being present, right now. After all that we have explored, we can now see this river with new eyes, with a deeper and more compassionate understanding. This river is not just a simple metaphor for the passage of time. It is the great, cosmic current of entropy, the unfolding of the universe from its simple beginning. It is the gentle curvature of space-time, the path that our world follows in its long, graceful dance through the cosmos. It is the ancient, biological rhythm of our own heart, a pulse that connects us to every living thing that has ever been. And it is the focused, gentle stream of our own consciousness, the only light with which we can ever truly see the world. We have wandered through the furthest reaches of science and philosophy, and at the end of it all, we arrive at a single, gentle, and deeply practical piece of wisdom. The past, we have discovered, is a story we tell ourselves, a reconstruction built from the fragile and fallible traces of memory. It is a real and powerful part of who we are, a place we can learn from and cherish, but it is not a place where we can live. The future, we have come to understand, is an act of imagination, a projection of our hopes and our fears onto the canvas of the unknown. It is a vital and necessary tool for planning and for dreaming, but it too is not a place where we can live. The only point of contact we ever have with reality, the only place where life is ever truly lived, where joy is felt, where peace is found, is this present moment. It is the only home we will ever truly have. The goal, then, is not to fight against time, to try to stop its flow, or to escape it. The goal is to learn to live in harmony with it, to dance with the river. This means learning from the past without being a prisoner to it. It means planning for the future without being consumed by anxiety for it. And it means learning to anchor our awareness, as often as we can, in the simple, profound, and often overlooked reality of the now. Every single moment, no matter how quiet or mundane it may seem, is a unique and unrepeatable configuration of the entire universe, a precious arrangement of atoms and of light that has never been before and will never be again. To be truly present for one of these moments, to feel the warmth of a cup in your hands, to truly see the colour of the evening sky, to truly hear the sound of a gentle rain, is to touch the fabric of existence itself. The great question is not, in the end, what is time, but rather, how can we live beautifully and peacefully within the time that we are given? Perhaps the answer is simply this: to be present for it, to feel its flow without resistance, and to find the eternal in each and every passing moment. Thank you for joining me on this gentle journey tonight. I hope it has brought you some comfort, some wonder, and perhaps a deeper peace. If you have enjoyed our exploration, please do consider liking this video and subscribing to the channel. It helps others who are seeking a quiet moment find their way here. Wherever you are in the world, I wish you a calm and deeply restful night. Sleep well,